Oh, I didn't change the section number. Let's do that real quick. While we're recording, what is this? 3, 4? 3, 4. Okay. Alright, and let me get my pen all ready. We'll be ready to go. Alright. First thing we want to do is let's just talk about, stick an X and Y axis right here. Let's just talk about this for a second real quick. And let's use different, actually. Alright, now I can change the color. Alright. Here we go. Watch this. What I'm going to do is just give you an example of what we're trying to do here. Here's a line, and it's on an X and Y axis. The black lines are just an X and Y axis. I'm not putting arrows all over the place. Alright, it's kind of a waste of time for right now. But I've got a line, and it's going on this X and Y axis right here. There's a couple things that are important about this line. First of all, what we just talked about yesterday. Okay, what was the whole thing we talked about yesterday? Yeah, give me a word. One word. Slope. Right. So we talked about the slope. All right, so we need to find the slope of this line. There's another thing that's pretty important. There's actually two places where it crosses the axis. Do you see it? It crosses the y-axis and it crosses the x-axis. For some reason on this equation we don't really worry too much about where it crosses the x-axis. What we do is we worry about where it crosses the y-axis. So according to our little equation that we're going to do, that point right there is really important. Now, for some reason, they use the letter B. I looked it up at one point. I think what they do is they use A to represent where it crosses the x-axis and B to represent where it crosses the y-axis. If you always wondered why they call the y-intercept B, I think that's what they do. But we hardly ever talk about where it crosses the x-axis. There are situations, I'm not going to get into it, but right now we're just worried about where it crosses the y-axis. So we use the letter B to represent that, but what do we call it? I just said it a second ago. We call it where it crosses the y-axis. What do we call that point? We call it the, well, we use B to represent, but what is it called? The y-intercept, right? We call it the y-intercept. Jot that down. Alright, we call that the y-intercept. And we use the letter B to represent the y-intercept. And this is the slope. What letter do we use to represent the slope? M. Okay? Alright. So we use M to represent the slope, and we use the letter B to represent the y-intercept. And so what we do is we come up with this formula. I'm not going to talk about how they come up with the formula or anything like that. We're just going to write it out. So here it is. Y equals mx plus b. Now we already talked about what these letters represent. What does the M represent? The slope. And what does the B represent? The y-intercept. I'll just shorthand it like that. Now, what about the x and the y? What's up with that? Now, I had a professor in college. He wasn't talking about this particular topic. He was talking about calculus, but it kind of works the same way. Sometimes I call this window dressing, the x and the y. All right, they're just there for good looks. All right, so really, the only thing that's going to be numbers are the slope and the y-intercept. Those are going to be numbers. This x is just going to be the letter x. This y is just going to be the letter y. Does that make sense? So when I write an equation, this slope is going to be a number and the y-intercept is going to be a number, but this is going to stay x and this is going to stay y. What basically the x and y represent, they represent any point on this line. So if I pick that point right there, whatever that x and y coordinate is, okay, it will work in this equation. We'll talk more about that as we go on, but I just want you to understand that the x and the y represent any point on the line. Not just any point in the world, any point where? On that particular line. Okay, that has to be a point on that particular line, and you can plug it in for here, and that equation will equal each other if you do. We're not going to get into that too much. So we have a slope, we have an intercept. Guess what? The brain trust in the math world came up with a name for this. What do you think they called it? The slope, right? We call it the Slope-Intercept Form. Not much of a stretch, is it? Because you got a slope and you got an intercept. Now it doesn't say the slope y-intercept form, but we just know that the intercept represents the y-intercept. And we call it the slope-intercept form of the equation of a line. This whole thing is called an equation of a line. I'm going to show you another one as well. I don't know if you learned this one or not. You may have in Algebra 1. My guess is you probably did. But this is I hate to say it's the most important one. It's probably the most used one, at least in high school anyway. It's probably the most commonly used form of an equation of a line. It seems like students really gravitate to this one among others. There's other equations of a line, and we're only going to learn 2 of them. And I think there's a couple more that you could do, but we're only going to do 2 of them. All right, so that's the slope-intercept form. That's really, really important. You did it in algebra. You're going to do it a ton in algebra 2. You're not going to get away from this. All right, you're going to use this quite a bit. Everybody good with that? Yep. Now there's another equation of a line. The first one's a slope-intercept form. Okay, the next one, let's see, is the point-slope form. And there are times when it might be better to use the point-slope form, or it might be better to use the slope-intercept form. It just depends on what they give you. Now what do you think this is? Well, they give you slope, and they give you a point. Is that point necessarily this point right here, the y-intercept? No, it could be where? Any point where? On the line, okay? That's what it is. So let's jot this out. Yeah.
Y minus y1
okay.
equals n parentheses x minus x1.
Okay, yeah. Did you remember that, or you just looked?
I remembered it, but I looked.
Okay. All right, there it is.
Yeah.
Remember how I said this x and y up here was kind of like window dressing? It's just going to be, when we write the equation of a line, it's just going to be the letter x and it's just going to be the letter y. We're not going to stick in, are you listening? We're not going to put in a number for x, or we're not going to put in a number for y. It's just going to be an x and a y. Same thing with this x and y. See this x right here and this y right here? It's just going to stay x and y. But this x1 and this y1 is actually going to be a number. Right? So they're going to give you an ordered pair. I don't know, let's just make one up. I'm just making this up off the top of my head. Let's say the point 2, 3. So where are you going to put that 2? Where in this equation are you going to stick that 2? In the x1, that's right. Where are you going to put that 3? And for the y1, good. And they'll give you the slope as well. All right, they'll give you the slope, I don't know, let's say it's 5/7 or something. And then you would just put that 5/7 in for the slope. Does that make sense? So that's where you're putting some numbers, okay? 2, 3, that's the x1, and this is the y1. So you're going to put those numbers in the appropriate spot. If they give you the slope, you're going to put that in that spot right there, and then we'll mess around with it. All right, I haven't done an example yet. We will here in a second. We good so far? All right. So let's pause this for a second, and I'll get rid of all this mess. I changed my mind. Let's do something else with this just real quick, just as a little example. I started off with it right here, but I didn't finish it off. Let's do the slope-intercept form. Here's a possible problem, I guess, that they could give you. They could give you, now it's going to get more complicated than this eventually, but this is as easy as it'll possibly get. They'll tell you the slope. I don't know, somebody give me a nice little slope. -1, 3. Okay, how's that? And give me a nice little y-intercept. 7. Okay, so if we're given the slope and we're given the y-intercept, they may not give it to you just like this. They may give you a graph, okay, and they'll show where it hits the y-axis, and you got to figure out the slope. There's all kinds of things, but eventually you'll figure out what the slope is, figure out what the y-intercept is, and then you have to write it as an equation of a line. If they say write it as a slope-intercept form, we're going to write it in this form, y equals mx plus b. So let's put some stuff in here. Now we don't put anything in for x, we don't put anything in for y, we just keep it those letters. Now we do replace the m, so that would be what? -1/3. What do we do with the x? Just write an x, and then you put the b. It's a +7, so you put +7. So that would be an equation of a line. Just looking at this equation, I should be able to graph it. Because what is that, without even looking at this stuff up here, just looking at the equation, what is the 7? That's the y-intercept, okay? So let's just real quick do this. Okay, watch. It's 7. 1, 2, 3, 4, 5, 6, 7. So we'll say 7's right there. So what do? You put just a dot at 7. The slope is -1/3. So what do? Just like we did earlier. Okay, down 1 and to the right, what? 3. Just like that. And what do you do once you get those two things? Just connect them, right? And something like that. It's close enough. There we go. That looks a little bit better. Oh, maybe not. Close enough. All right. So yeah, you just connect the lines like this. Now, don't just, when you do this, when you have the 2 points, don't just connect from one point to the other. all right, as a line segment with those as endpoints. Just make sure it goes all the way through like this. All right, just looks a little nicer like that. All right, so that's how you would graph something like that. That's pretty simple. What about point slope form? Again, let's just use the numbers we've already used up here. They give you a point, they give you a slope. Let's write it in point slope form. So we write y minus what? 3 equals m, which is 5/7, then parentheses, x minus what? x1, which is 2. And that's it. That's written in point slope form. Now, they may ask you to write they may give you something in point slope form, and they might ask you to change it to slope-intercept form. What would we do to this to change it to slope-intercept form? Yeah, I would add the 3, but I'd also distribute the 5/7. Let's do that first. Now, we picked kind of ugly numbers, but that's okay. So watch. I'm going to do one step at a time. So I'm going to distribute the 5/7 first. What do we get? 5/7 x minus, what's that? 10/7. Is that right? When I multiply those together? Sure. Then add a 3 to both sides. If I add a 3 to this, I put it over 7, what's that going to be? 21. I'm just doing this real quick. If you don't understand, you can always do this on your own. Alright, so 5/7 x plus what would that be? 11/7. And that's it. Now it looks like slope-intercept form, doesn't it? So we changed it from point slope form to slope-intercept form. If you didn't catch on to that, go back and look at it. Take your time with it. Alright, do you understand why I made it 21/7? Because I found a common denominator. 21/7 is the same thing as 3, isn't it? 21/7 is 3, isn't it?
Yep.
Yeah, Jaden, do you see that? 21/7. 21 divided by 7.
Yeah, but 21 plus 10 is 31.
It's negative 10. It's a minus 10.
Oh,
Alright, it's a negative 10 plus 21. So you subtract them, which is 11. Take the sign of the larger number, so it's 11/7. Right? Because 21/7 is 3. So I added a 3. I just did that in my head. I just figured, okay, I got to find a common denominator, right? Yeah. See, we don't have enough practice. When you guys are younger, you don't have enough practice with fractions. And when I do stuff like this, so many people are confused with this because you know what students are used to doing with fractions? Talk to me. Yeah, but how do you do calculator? Right? You guys, who does that? As soon as they see a fraction, what's your first instinct? Pull out the calculator. Yeah. Okay. That shouldn't be your first instinct. That's definitely not. Look, I'm a big calculator fan. I love a calculator. I've got several of them. Okay. I even have one downloaded on this computer. I can pop up and use a calculator. Okay. I've got one on my phone. I got a nice scientific. I even downloaded a scientific calculator on my phone. All right. So I love calculators, but there are times when you don't need to use a calculator, and there's situations like this where you should be able to do this without a calculator. All right, enough said about that. I don't want to go on my calculator rant because I have a good one. All right, but I'm not going to use it today. Maybe some other day. All right, let's stop this and go on to another part of. Well, let's see. Yeah, we'll do a couple examples here after this.